Are you looking to learn about storage on the Azure cloud? If so, this video is for you. Hi, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers. And we're an organization that's dedicated towards building high-performance cloud computing careers. Personally, I've been working in technology for over 25 years now, and I've been helping others get their first tech job or get promoted in tech for more than 2 decades. And I want to help you either get cloud hired, cloud promoted, or become a cloud computing expert. Today, we're going to talk about storage on the Azure cloud. Most specifically, we'll be discussing Object Storage, otherwise known as Blob Storage. We'll be discussing Block Storage, otherwise known as Azure Managed Disks. And of course, we'll be discussing Azure File Storage. Now, we're going to get pretty deep into the idiosyncrasies of the storage, how it works, and why to use the type. So this can be fun. We're going to get our thinking caps on, and we're going to get technical today. We're going to begin by object storage and discussing object storage. So to begin, what is object storage? Well, object storage is a type of storage area network, meaning it's network storage. And this means you'll have to access it via a network, like an IP network. And when we deal with object storage, what happens? We have data, and this data gets broken down into something called an object. That's why it's called object storage. Now, when the data gets transformed into an object, there's something really great associated and attached to that object, and that's called metadata, which is data about the data, which tells us what it is. So every object is going to have a unique object identifier with metadata, so we can find it when we need it. We can search it, we can query it. It's great. Object storage is a wonderful type of storage. It's known as worm storage, meaning write once and read many times, and here's the reason. Object storage does not work with files that change frequently because as soon as we take the data and turn it into an object, if that object is modified by even 0.1%, we create a new version of it, which could fill up our object storage very fast if we're not careful. So, object storage, not mounted by computers, not used by computers, but used for backup purposes, archival purposes, software distribution purposes, backing up of your system images, photos, videos, songs, that kind of thing. Big things that we write once and read many times. And we'll be using it through a wide variety of use cases, which we'll discuss, but that's what object storage is. Now, every vendor has their version of object storage. With regards to Microsoft Azure, they call their object storage Blob. Google, as it would turn out, would call it cloud storage, and AWS would call it S3. Guess what? It's all object storage. So why do we use object storage? Well, store large amounts of storing unstructured data, like text. Application data we want to store files for analysis later. Streaming audio, video, we can stream it into object storage and save it. We can use it for disaster recovery purposes, backup and restore, software archival. So very useful in a lot of use cases. We're constantly going to be using Azure Blob Storage. Now, when we're dealing with Azure Blob Storage, we really have 3 kinds. We've got block, DFS only, we've got an append blob and a page blob, and we'll talk about those. We'll also talk about blob storage resource types, which means we're going to talk about the storage account, a container within a storage account, and a blob within a container. So like I said, we're going to get pretty deep. Now let's talk about the 3 kinds of blobs: block blobs, append blobs, and page blobs. We'll begin with block blobs. Block blobs store text and binary data. Next, we have append blobs. And they're very similar to block blobs, but they're optimized for append optimization. So great for logging data from, say, your virtual machines. And then last, we have page blobs, which really stores random access files. And they basically serve to function and assist virtual machines in the way they operate. So let's talk about some blob resource types. We have storage accounts, and this realistically addresses storage with unique account identifier name. And that's what we can think of as a storage account. Now we can put a container in the storage account, which realistically is going to organize the blob inside of the storage account, and it's going to feel like a file system directory, but it's just the way we structured it to feel this way. Remember, object storage is flat storage, and it's basically like we have a database pointer that points to the storage, but we can create a container in the storage account, and it's going to make it feel like a file system directory, so it's going to feel like traditional storage for us. And of course, we can have a blob and a container, and this can support a block, an append, or a page operation, or page blob. So now you know the types of blobs that we can use in Azure Blob Storage. As you can see in this graphic that we've deployed, you can see we have an account Sally. And in Sally's account, we've got a container that has pictures and movies. And inside the blob, we've got some images and movies. So that's realistically speaking what we're talking about. So let's talk about securing our data in Azure Block Storage. Well, obviously we want to encrypt it. And Azure Block Storage by default supports encryption at rest. So as soon as you place something in Object Storage or Blob Storage in Azure, it's going to be encrypted and decrypted with AES 256-bit encryption. So good, raw, strong encryption for your data. And realistically speaking, your data is going to be encrypted in primary and secondary regions. So whether it's replicated or not, regardless of your geo-replication, it's going to be encrypted, so your data is going to be secure. Now let's talk about some client-side encryption. We can use client-side encryption to encrypt, say, client applications using the Azure Storage Client Library for .NET prior to uploading information on Azure Storage, so we can encrypt it on the client side as well. We could also use this to decrypt the data while downloading from the client. And by doing it this way, it's going to encrypt and decrypt using something called an envelope, basically speaking on the fly. And realistically speaking, this is a fantastic way to encrypt your data before you send it to them. Now let's talk about the access tiers that we have, or the performance tiers for our data with regards to blob storage. We have the hot access tier, and guess what that's used for? It's optimized for data that we're going to use frequently accessed or modified data. Now when we're using this, it's going to have the highest storage cost, but the lowest access cost for our frequently accessed data. Now, we have something called the cool access tier, and this is for infrequently accessed data. So if you're going to store something and you're going to use it infrequently, and you're going to store it for, say, at least 30 days, we're going to use this because it has lower storage costs compared to the hot tier, but we're going to pay a higher cost to retrieve our data. Now, the last form of storage we're going to talk about is the archive tier, and this is for data that you're not going to use very frequently, but you might need it on occasion. So this is basically offline storage. It's good for randomly used information. Very limited cost, very inexpensive cost to store it, but we're going to, retrieving it is where we're talking about. So this is optimized for things that you're not going to use very frequently. So let's talk about it a little further. With regards to the hot access tier, think about it for something that's going to have heavy read and write activity. So lots of processing, migration, etc. We're going to keep it here when we use it frequently. When we don't need it as much, we can move it to a cool access tier. But for the data when we need it, hot access. A little bit more about the cool access tier since we previously defined it. This is really good for short-term data backup and disaster recovery. It's excellent for infrequently accessed information and older data sets when we might still need immediate access, but we don't need it that frequently and we're willing to pay for it when we need it for reduced storage costs. So ideal for large storage sets requiring cost-effective data storage until we need it. And it's not going to be quite as available as the hot tier, but don't worry, it's around when we need it. So kind of keep that in the back of your mind. Now let's discuss cool access tier. Now, like I said before, this was good for short-term data backup and disaster recovery. It's excellent for infrequently accessed data, older data sets that you might need immediately. It's excellent for large data sets that require cost-effective storage while we need them, but it's going to have slightly lower availability than the hot data tier, but it's going to have good retrieval latency and throughput. So kind of keep that in the back of your mind. It's still there and it functions quite well. Now the archive data tier, this is really intended for storing rarely accessed information. So long-term storage, maybe secondary backup, and this is going to give you by far the lowest storage costs, but with higher data retrieval costs and a lot more latency compared to the other tiers. So good for compliance data. Maybe you're in healthcare and you've got to store patient records for a certain number of years, or banking data where you've got to store chat transcripts for long periods of time with thousands and millions of customers, those kind of things for regulatory purposes. And like we previously mentioned, this is good for data that's expected to remain in this tier for at least 180 days, or you're willing to pay early deletion charge if you delete it prior to that time. So now you know what that's used for. So let's talk about Azure Blob Storage Lifecycle Management. Now, data typically has a life cycle. We need it fairly frequently for a little while, then we need it occasionally for a little while, and then for the most part, we almost never need it. So you can set up lifecycle management. And what this is, it's a rule-based policy that will move your data for you automatically, so you can set it up that you're paying for the appropriate storage based upon your needs. So realistically speaking, we can go from hot to cool to archive based upon our things. And realistically speaking, this is the terrific way. We can have set up a lifecycle policy. You can even delete the blob at the end of the lifecycle if we want. And we can define up to 100 rules. And this is really great. So we can put up to 10 prefixes for rules to a container or a specific subset of blobs. But the point is, take your data, use it for 30 days. Say, maybe after that, move it to the cool tier where you don't use it very frequently for a couple months. And then when you're done with it, move it to the archive tier where you're never going to use it, but you've got it stored for compliance purposes, or maybe you'll use it 10 years later for machine learning purposes. But the point is you can store your data for whatever you need it. Now, when you're dealing with object storage, by default, anytime a file or an object is modified, it's going to create a new version. Now, the cloud providers automatically disable that for you, because otherwise you could deal with a file and create a million versions in the course of a day, and they know that obviously you'd get a bill for that and not be happy. But if you want object storage to work the way it used to, the way it's supposed to, you can enable versioning. And what that does is anytime you modify an object, it gets changed. So imagine a Word document that we edit 1,000 times. There'll be 1,000 versions of it. And guess what? If version 896 got corrupted, you can go to version 895. So there's a lot of reasons to use versioning. But if you keep 1,000 versions of something, you're paying for 1,000 times the storage. So kind of keep that in the back of your mind. That's what we're talking about, versioning. It's used for the restoration of earlier versions that were accidentally deleted or got corrupted, etc. We can restore a container through a soft delete function. And let's talk about soft delete. Blob soft delete enables you first, let's say you delete something and you want to restore it. It's kind of like it puts it in a recycle bin for a little while and you can restore it from where it's at. So kind of understand that's what we're talking about. We can restore previously deleted versions, etc., etc. So we're able to restore a container. So excellent, excellent, excellent. So let's see what block versioning looks like. As you can see here, we've got a blob.txt. We've created versions, 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 and more versions. And now you can see how and why that functions. Let's talk about soft delete for blobs. Now, what is soft delete? It's going to protect an individual blob version and a snapshot from accidental deletion or overwrites. So what happens, you go to delete something and it gets soft deleted. And it sort of sits in something kind of like a recycle bin. And after a period of time, the object is going to be permanently deleted. And you can keep your soft delete retention period for anywhere between 1 and 365 days, meaning how long it's going to be there before it gets completely eliminated for your system. So if you deleted something yesterday by accident, it's going to be there for a month. You got 30 days to get it back. So keep that in the back of your mind. But you're storing, well, you're dealing with storage while your stuff's still there. So the retention period represents the period of how long it's going to be after you delete it until you can actually bring it back. So keep that in the back of your mind depending upon what you need to do. Now, what about soft delete for containers? Well, it protects containers similar to a blob from accidental overwrites and deletes because it's pretty easy to delete things. So if you are to delete a container, during the time frame the containers and the contents are stored in the soft delete, you can restore them back exactly the way they were. Now, after the time frame expires, they're deleted permanently, so they're completely lost. Now, the retention period, again, is between 1 and 365 days, but the soft delete for containers, the default delete retention period is 7 days. So good news, you make a mistake and you've got upwards of a week to fix it. Kind of keep this in the back of your mind. So you can see here, we've got a container, we've deleted one, for example, and we can bring it right back, which we love. It's a great functionality to protect against accidental mistakes. Now let's talk about organizing your data in blobs. So the blob metadata is going to consist of some name value pairs of ASCII characters. So you've got a name, and you call it doc type, and it's got a value, student-list. So we know exactly what it is. That metadata is just wonderful. We've got a combination of the account name and the storage blob endpoint. It forms a base address. And here's the good news. It looks just like a URL. For example, I could do something like https://gocloudcareers.blob.core.windows.net. I can basically set up a fully qualified domain name for a blob. And a blob can contain any combination of case-sensitive characters, and a blob name can be pretty descriptive, up to 1,024 characters long. And when you set up these blobs, you can set up the feels like a folder, even though they're not. We can set up a delimiter, a / or / to feel like a file structure in a Windows or Linux system. So it's, this is some really way we can organize it in a way that makes us humans feel like it's a folder, even though it's not. Remember, it is object storage, and object storage is flat storage. Basically, it's like a database. We've got data and a pointer to it. But we can organize it with delimiters. And by doing that, for example, we can make it look and feel like a regular folder. Let's talk about tuning Blob for performance. We've got the concept of a shared access signature. And what this does, it restricts access right to storage resources. And typically we can do this at the account level, the service level, or via user delegation. Now let's talk about scalability. We can stay within scalability targets or use higher performance storage. Now, if we want to basically improve the performance, we can basically enable load balancing by partitioning, which basically means just creating more blobs. Some other things to keep in mind is, remember, object storage is network storage. So if you don't have enough network bandwidth, you won't have enough performance. So keep that in the back of your mind. And we can potentially use some caching, which basically means storage of data that's frequently accessed with little changes to further improve performance. And for the customers that are using .NET, we can deal with some .NET features and functionalities as well. You talked a little bit about encryption, so let's talk about the two options. Client-side encryption, meaning you do it on the way to get to your storage. So your data is encrypted before it's uploaded. Now there's server-side encryption too, and which basically means once you put it on the server or storage, it gets encrypted for you. Now there's 3 ways you can do this. It can be done with service-managed keys. And basically speaking, this is a great way to do it flexibly for managing the keys. It gives you a great balance of control and convenience at a relatively low cost. That's a service-managed key. The next thing we can talk about is a customer-managed key. And guess what? For customers that really want control, this is great. Bring your own keys. Think of it this way. And then there's this combination of a service management key in customer-controlled hardware. So we'll still be talking about where you take your keys and you manage it yourself, and you keep it in your on-premises environment via host your own key kind of configuration. So those are your 3 options. So let's talk a little bit more about Azure encryption models. We've got disk encryption, which realistically speaking, protects your Linux and Windows virtual machines through disk encryption. And whether it's either encrypted via Linux dmcrypt or Windows BitLocker, respectively, based upon your operating system, it's going to be protected with the Key Vault subscription. Encrypted virtual machines using the key encryption key can be backed and restored by using the Azure Backup Service. So this is, realistically speaking, a great way to back up, store, and encrypt your data so it's private. So anybody breaks into the Azure network and steals the hard drives, nobody can use your data. Let's talk about storage service encryption. Realistically speaking, this is data at rest in Blob storage or file shares that are available for encryption about the client and the server side. And client-side encryption of Azure Blobs, there's various options here. You can encrypt it with .NET, and there's lots of other ways to encrypt your information prior to sending it to the server. Real speaking, what we're talking about is object storage that we're talking about. Now let's discuss Azure Virtual Machine Storage. So when we deal with Azure machines, we're going to be talking about both the block storage kind, but also ephemeral disks. Now I'd like to start with the ephemeral disks first. The servers themselves, for which all the Azure virtual machines are located, have high-performance hard drives in them. Typically speaking, they have NVMe drives in RAID array form that are blazingly fast. Now, these systems are the fastest hard drives we can deal with, by far the fastest performance in terms of IOPS. But here's the thing, they're ephemeral, which means when we use a system and the system is terminated, we lose what's ever stored in them. So we don't want to keep a lot of information on transient or ephemeral storage. Once the OS is deleted, it is gone and gone forever. So keep that in the back of your mind. But we can quickly reset a virtual machine image to its original state with an ephemeral disk. And ephemeral disks come with the server completely free of charge. But remember, It is transient, so don't store anything critical on ephemeral disk, but really blazingly fast performance for your operating system. Now, we can have our OS disk, which can be on ephemeral storage, but our data disk needs to be on block storage, something that's persistent, that doesn't go away upon termination of an instance. So that's where we're going to talk about Azure Block Storage, which is also called Azure Managed Disks. So let's talk about block storage for a minute. Again, this is a storage area network like object storage, but it's different. In block storage, the data is broken down into blocks versus objects in object storage. Now, each block has a block identifier that is unique. Now, why is block storage so cool and used in the cloud computing environment? For the following reason, and the data center. Block storage decouples the server environment from the storage environment, which means your storage can be anywhere where you've got IP connectivity. And the blocks are placed wherever it's most efficient, so fast and efficient for the cloud provider. Now, we got to remember, in the cloud, we'll talk about block storage being fast, but it's not fast, but it's the fastest we've got in the cloud. And we use block storage because the way it stores data in blocks looks and feels a lot like a hard drive on a computer. It's not, but it looks and feels like it. So we can use block storage. We can mount it in our virtual machines, and it looks and feels like a local hard drive, even though it's not. It's network storage, but it feels that way. So we're using this to store information that we don't let it go away on an instance termination. So it's good, strong, persistent storage, so keep that in the back of your mind. Now, when we're dealing with Azure Managed Disks, we are dealing with block-level storage volume, and they are designed for mission-critical workloads. It's almost as if they're a virtualized physical disk inside the system, but they're not. They're network. They're highly persistent, they're highly scalable, and the performance is the best we're going to get in the cloud. Now, we can have users who can create a maximum of up to 50,000 virtual machine disk types in a subscription, so lots of these we're going to be using. And realistically, we can position them in a way that we can avoid single points of failure. So we're dealing with block storage in the cloud, Azure Managed Disk, and it is absolutely critical information. As you can see in this graphic, we've got a virtual machine where we've got an OS disk and we've got a data disk, otherwise known as our virtual hard drive. Again, this way, fast boot for the operating system with the instance or the ephemeral storage, and the data disk, which is block storage for everything that we want to hold on to. So when we're dealing with Azure Managed Disks, let's talk about how we can back them up. We can create what's called the snapshot, which is a perfect entire read-only copy of the entire disk. So bit by bit copy, it's unbelievable. It's a point-in-time backup. It helps with troubleshooting virtual machines because you can always launch a new one from the snapshot. We can snapshot it's everything. It's not just a file, it's the entire drive. It's made into an image. It is a snapshot. It is a perfect replica. So the best backup you could possibly do. Now you know what that is. That's a full snapshot. But what if we created a full snapshot of our system and we do incremental backups each day? That means we basically can make a point-in-time backup. So we create a snapshot, and then we only have to capture the changes. So we make the main and capture the changes, incremental. So it's like an incremental backup in the system that we've been dealing with for years. We create an opportunity to restore the system at a point-in-time snapshot. So you got the original. So let's say we've got 1,000 snapshots. I want to restore the snapshot 565. I can, bit by bit, identical copy. So excellent, excellent, excellent opportunity to create a cost-effective backup. What's it look like? Well, here you go. You got an Azure Managed Disk you can see in this graphic where we've got an incremental snapshot 1, 2, and 3. And that's what we're dealing with. You can see it very clearly in this graphic. So since we're dealing with block storage in the Azure cloud, let's talk about the options. We're going to have ultra disks, premium disks, standard disks, and hard drives. Now, they're all different flavors and performance. So let's talk about Azure Ultra Disk Storage. Now, this is the best we're going to get on the cloud. So think about it and remember, it's the best we're going to get. And this realistically gives us the ability to really tune our virtual machines. In fact, we can even tune performance parameters without even rebooting the virtual machine, which is pretty cool. Now, this Azure Ultra Disk Storage is the fastest block storage we get. So it's designed for high I/O, input-output intensive workloads, transaction-heavy workloads like a database, for example. Lots of read and writes per second. Now these volumes can get relatively decent size, upwards of 32 terabytes, and we can increase them if necessary by calling Azure support. Now, how much performance are we dealing with? We're dealing with about 300 IOPS per gigabyte, or about 160,000 max per disk. So if you want to compare that to standard hard drive performance, a disk at Best Buy, say a Samsung 980 Pro for about 150 bucks, will get you about 1 million IOPS. So this, at best, is about a sixth of the speed of a regular standard non-volatile hard drive that you can buy at the store, because it's block storage, it's not local storage. But still, it's the fastest we're going to get in the cloud. Now next is premium SSD. Now this gives us a good blend of high performance and relatively low latency, and it's intended for, high input-output operations. It's good for mission critical applications, and it's designed for things that need millisecond latency. So it's not super fast, but it's relatively good. Think of SSD drives. And this will give us upwards of 7,500 IOPS and about 250 megabit per second throughput. So it's about half the speed of a SATA-based SSD, but you keep that in the back of your mind. And we can do some bursting, meaning if you got some unpredictability and you go over your speed for a short period of time, it will support that. That's called bursting. Now let's talk about a standard SSD. Now this is intended for workloads that require consistent performance but low, not a lot of latency, so lower input-output operations per second. And this is an optimum choice for varying workloads. Maybe you've got some on-premises workloads. It's going to give us some high availability, great persistence, and acceptable latency. It's good for web servers, non-production workloads, things that don't need really good performance, maybe a lab environment. And your input and output operations per second and throughput are going to vary based upon your traffic patterns. And there's a little bursting to go above and beyond for a short period of time with this option as well. Keep that in the back of your mind. Now, the last type of block storage we have is the standard hard drives. Now, this is magnetic hard drives, so low cost and reliability. It's really designed for workloads that are dealing with latency tolerant applications, dev tasks, less critical information. And our performance is going to vary dramatically with workloads because it's standard hard drives. Now, we've talked about block storage, we've talked about object storage, and we've talked about the server ephemeral storage. Let's talk about file storage. So what is file storage? File storage is traditional storage, like the hard drive in your computer. You save a Word document and it's a file. You take a picture of your cat Cindy and it's a file. That's file storage, and it stays as a file on the drive. So file storage could be the flavor of, say, a hard drive in your local computer, or it could be a file server. Windows file servers, for example, typically use the NTFS, and they use to store their drives, and they use a standard file system, and they use the server message block protocol. Network file system, by comparison, is the Linux file system that was created by Sun Microsystems many years ago. That's now owned by Oracle, and it's used on every basically Linux and Unix system in the world. So NFS, so keep that in the back of your mind. There are our file storage and our network file storage options. So Azure gives you access to file servers, and they have something called shared access. And this is a fully managed file storage service, which means you can, if you have Windows systems, access the file storage service with the server message block protocol, or if you got a Linux or a Unix system, you use the NFS, or network file system protocol. This is a managed replacement for your local file servers. So you could lift and shift your file service data from your data in your data center, move it onto this Azure managed shared files, and it's done. So you can store things, you can store dev or testing information, or information that needs to be seen by a lot of servers at the same time. As you can see in this graphic, you can see how Azure Files is integrated with all kinds of clients and uses. So Windows, Linux, everybody can access the information and store information and share information. So Azure File use cases, use it to replace your file servers on site, or use it as a file server that you could use on the cloud if a lot of your systems need to access the same data at the same time. So what did we talk about today? We talked about storage on the Azure platform. We talked about object storage, or blobs. We've talked about block storage, or Azure managed disks. We talked about the server storage itself, or the ephemeral storage, and we talked about Azure File Storage. I hope you've enjoyed this discussion on Azure storage. I look forward to seeing you in another video coming very soon. Take care. I'm Michael Gibbs, the founder and CEO of Go Cloud Careers, and I want to help you build the best cloud computing career. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. We have a free How to Get Your First Cloud Architect Job webinar, where we tell you all the things you need to do and know to get your first cloud architect job. In addition to that, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I've known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you to all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architects.